Hello and welcome everyone. We will be studying the Sean Pra's add Leetcode patterns together. And the very first question on the list is contains duplicate. So we are given an integer array nums and we want to return true if any value appears at least twice in the array and want to return false if every element is distinct. So we know that we are given an array of integers and we want to return true if the array has duplicates. On first sight, we can see that this will return true and this will return false because this one is repeated here, whereas this has all distinct number. Now, how do we go about it? So our first instinct might be to, one, traverse the entire list. And when we say traverse, we mean basically loop through the entire list. And we want to have a system of storage whereby when I visit the first item at index 0, I want to store it somewhere. And then when I visit the next item, I want to check, okay, have I visited this number? And if I have, I want to return true immediately because it doesn't matter if every element in the array are duplicate. As long as there is a single duplicate, I can return true immediately. Now we see that. Now the question is, how do we go about storage? Because I assume that traversing might be easy, but how do we store the numbers? Now there are different ways of storing anything basically in programming language. There are data structures we can store with list, we can store with maps, we have hash tables, queues, stacks. Basically there are numerous system of storage, but what will determine what we use to store is what we need the elements for. If we store in a list, we know that we want to go through every element, right? So imagine I store one and now I have to, in an array or a list, for instance. Now I want to check if 2 is in this list. That means I have to loop through this entire list to find these 2. So basically I would be looping, or rather I would loop to store, and then I would also loop to check if this element exists in the storage system. That's not very efficient. Now, can we do it better? Yes, we can. We can use a key value data structure such as hash table or map or set. Key value data structure basically means that we can have one and have some value. Maybe in this instance, maybe it's true, maybe 2, maybe something like it's true, like yes, basically we've gone through this, so they exist in our data structure. And the good thing about key value data structure is that they have a constant lookup time. So basically, unlike list, we won't be traversing the entire storage system to find if a value exists in that array. Now, to just recap, what we are saying is, one, let's traverse, let's loop through every element in the array. And 2, while looping through, let's store it. And 3, before storing, we kind of like check our storage system, that does it exist in our storage system. If it does, then immediately we can just check out and return true. If after getting to the last number and it still doesn't exist, then we return false. Now this might be a good time to pause this video and give it a try. If you've clearly understood it, you might be able to try to code it up yourself and try to really understand, if you really understand what I've been explaining. And if you don't, or if you still need extra help, then here is the code solution. So first we want to have a storage system basically where we want to, this is where we'll be storing elements that we visited. Now I'm going to be using a set data structure because set only stores distinct numbers. You can choose to use a hash table, a dictionary, or anything really. And I'm going to be traversing every element in the array. For num in nums, I'm going to check if num exists in the storage, then I want to return true immediately, because if you recall, it doesn't matter if every element in the array has duplicates. As long as we have found a duplicate, as long as it contains a duplicate, then we return true. Otherwise, we just store this number, the element we currently are on, to our set. So we are saying that if 1 does not exist, we have 1, 2, 3, 1. Now we're going through 1. Does 1 exist in our set? No, it doesn't. So we add 1. Does 2 exist in our storage? No, it doesn't. We add 1. We add 2 rather. Does 3 exist in our storage? No, it doesn't. We add it there. Does 1 exist in our storage? Yes, it does. Then we return true. Now, if this were 4 and 14, let me use 4. If this were 4 and we're at the end of our array and it doesn't exist in the storage, we've added everything, what do? Then we return false. That no, this doesn't contain any duplicates. Now I'm just going to run our code. This passes, and then we can submit. And cool, we see that this passes. But a cool trick I also used to learn more is to check. Leetcode has this thing where you can see where you are currently ranking your runtime distribution. That's how much time your code spends to run and how much space you have used. I mostly check the code, some of the best code that ran really fast, and I want to see what they did better than I and what I might have done. And I can say that, well, this is not really different from what I've done, but I don't know why it ran faster, but yeah. Okay, this now I see that, okay, this is a clever trick. This I could not have thought of this one. I didn't think of this, but this is a very clever trick. However, I don't think in the context of an interview it might be really advisable to submit this, but this is very clever and I would definitely be impressed because I didn't think of it myself, so I can't really say. So this is very clever, and so this is why I like checking the runtime distribution. Also, I check the space distribution to see, okay, someone used less time than I. This might be interesting to see. And yeah, I said that this is also a cool trick where they're using counters to count the number of occurrences. Counter is a Python inbuilt function where you can count the number of occurrences of each item in a list, and then if anyone has a count that is greater than 2, return true, otherwise return false. Again, this is very clever and it's a good way to read up code and learn more. I'll see you on the next video where we continue to study the Sean Pratt add Leetcode pattern. You can visit it here. Leave a comment below. Let me know what you think, what I could have improved on, what I can improve on, and please support the channel, subscribe, like, and thank you so much. Bye.